Most of you have probably experienced something called the Doppler Shift, although you probably didn't have a name to go with it when you experienced it. It's a phenomenon that has to do with waves. If you have a source of waves, let's imagine the source producing a wave front that moves out away from it, and then the source produces a second wave front to give you a wavelength of about that long. You will hear, according to that wavelength, a certain pitch of sound if it's sound waves that are being produced. But if the source of the waves itself is moving, the first wave front moves out like this, but the source follows it and then produces the second wave front, the two wave fronts will be closer together than they were before. That shorter wavelength will be experienced as a higher pitch. On the other hand, if the source is moving this direction and the wave goes out this way, the first wave front goes out this way, and the source moves, and then the second wave front is produced, then the wavelength will be longer than it was when the source was not moving. Consequently, you'll hear a lower pitch. Now let me demonstrate that with some sound waves produced in this speaker on this long cord. I'll start by just turning it on so that this source of sound is stationary, and you'll hear a certain pitch. But it's a nice steady pitch. Now I'm going to take that source of sound and I'm going to whirl it around my head. Now as that source of sound comes towards you on this side, the Doppler shift will raise the pitch of the sound, and then as it goes around here and moves away from you, the Doppler shift will lower the pitch of the sound, and as I whirl it around my head, you should hear an up and a down, an up and a down, that is in synchronization with the speed at which I rotate or spin the speaker around my head. So listen. That's a Doppler shift in the sound that you can hear. It goes up and down, but when it's stationary, you get a nice, steady pitch.